Hello everyone, welcome to our group assignment. Here we're gonna learn about integrals. In this chapter, we will explain to you about indefinite and definite integrals, and second is about fundamental theorem of calculus. First, let's we go to learning outcomes. At the end of this chapter, students should be able to evaluate indefinite integral using basic integration rule, evaluate indefinite integral using a limit, evaluate a definite integral using a fundamental theorem of calculus, evaluate the average value of a function over a closed integral, understand and use the second fundamental of theorem of calculus, and understand and use the net change theorem. Next, let's we go to the first subtopic.
I will explain topics about indefinite integral and definite integral. Did you know which integral consists of family of all antiderivative of function and denoted by a special symbol integration? Yes, correct. It is indefinite integral. Let's take a look at the definition of indefinite integral. Indefinite integral is a set of all antiderivatives of function f(x). It's called indefinite integral of f with respect to x, denoted by the integral of function f of x with respect to x. The symbol integration is the integral symbol. The function f is the integrand of the integral and x is the variable of integration. This is the list of indefinite integral formulas. As you can see, there are many formulas of indefinite integral. Next, there are a few properties of indefinite integral, which is constant multiple rule, sum or difference rule, and linearity rule. Let's do some examples. The first example asks to evaluate the integral of the function x plus x squared with respect to x using the indefinite integral formula. The problem of this question is the integral of the function x plus x squared with respect to x. First, we have to apply the sum rule. Then, we write x as x to the power 1. Next, integrate the function by applying power rule. Then, simplify it. Do you realize the general pattern of integration is similar with differentiation? It starts with write the original integral, rewrite integral, and simplify. This is also known as basic integration rule. Let's proceed to example 2. It asks us to describe the antiderivative of 5x. The problem is the integral of the function of 5x with respect to x. You can solve this by applying basic integration rule. Start with the original integral that has applied the constant multiple rule, rewrite the x, integrate the function using the power rule, lastly simplify it. You can try solve these exercises and check the answer given later. Let's proceed with definite integral. It will be considered as definite integral if a function of x is continuous on the interval from a to b. Then the integral of the function of x with respect to x from a to b is equal to function of b minus function of a. Let's try this example. It asks us to evaluate the integral of the function of x squared plus 5 plus x to x by using the definition of definite integral. Start with identifying its problem, then proceed it with basic integration rule and applying the theorem earlier. Lastly, we will get the answer in the form of a number. Difference with indefinite integral. This is the list of properties of definite integral. You can use it accordingly to the problem given. This example 2 asks to verify the following integrals by applying theorem earlier. The first one, we will use the theorem B. Second, use the theorem D. Third, theorem A. Fourth, theorem F. Fifth, theorem C. Lastly, theorem E. You can try this exercise given to test your understanding about the use of properties of definite integral and integrate functions using limits. That's all from me about indefinite and definite integral.
Okay, let's we go to the next subtopic.
Fundamental theorem of calculus. Guideline for using the fundamental theorem. First, find an antiderivative of f, evaluate a definite integral. Second, apply the fundamental theorem. Third, not necessary to include a constant of integration c in the antiderivative. Example 1. Evaluate definite integral involving absolute value. Integrate 0 to 2x minus 1 dx. Integral in two parts. The answer is pi over 2. Average value of function. If f is integrable on the closed interval ab, then the average value of f on the interval is 1 over b minus a integrate ab fx dx. This is the graph of average value. The area of the region under the graph of f is equal to the area of the rectangle whose height is the average value. The second fundamental theorem. If f is continuous on an open interval I containing a, then for every x in the interval d per dx, integrate ab ft dt equal to fx. If a function is continuous, you can be sure that it has an antiderivative. 2. Find the derivative of fx equal to pi over 2x cubed cos t dt. Using u equal to x cubed, apply chain rule. F prime x equal to dy per du d minus multiply du per dx. The answer is cos x cubed multiply 3x power of 2. Last, net change theorem. If f is continuous on the closed interval ab and f is an antiderivative of f on ab, then integrate ab fx dx equal to fb minus fa. The theorem of net change theorem is The definite integral of the rate of change of a quantity f prime x gives the total change or net change in that quantity on the interval ab. Integrate ab f prime x dx equal to fb minus fa is the exercise and the answer. Thank you.
That's all. Thank you for watching. Don't forget to watch our next
Diffusion
video.
technique is used to integrate composite